in this circuit, we're being asked to compute I naught using source transformation. While the use of source transformation is not always possible, in this particular example it is, and I'll mostly use just source transformation to solve this particular example. But what I want to do is I want to highlight that branch in here because it contains I naught, and I want to make sure that I don't transform it by mistake because this is the current that I'm after. And this is typically what I do. It's like if I'm using source transformation, I highlight the current or the branch that I need. Like for example, if it's a current, branch current, if it's a voltage, I'll just highlight that element just to make sure that I don't transform it and lose it by mistake. All right, so let's do that. I think what we can do is, and I'll highlight it in a different color, for example, in here, we can do these here together. For example, this is a parallel resistor and current source. We can convert it to a voltage source in series with that 6 ohms. We have something similar in here, for example, for this 1 ohm and the 5 ohm, they're in parallel. We can convert them to we can convert them into a voltage source. And I also believe that we can convert these series resistor and voltage source into a current source in parallel with that particular 17 ohm. So let me just do that. I will just redraw them, and I think I'm going to draw these in green so that you can track it with me. Of course, it's like you have just to try to figure out which conversion works at what point, and I have thought about it ahead of time, and I think these conversions will actually make sense. So, and you'll see that why in a minute. I'll do the 3 conversions together in the next iteration, but you don't have to do it 3 at a time. You can just basically do it 1 at a time. I'm trying to save a little bit of time here. All right, so the first one in here will be just a voltage source, and typically just a comment in here, if the current is moving upwards, that means the voltage will be on the top, and the voltage positive will be on the top and the negative will be at the bottom. Okay, and typically it will be replaced with the same 6 ohms in here in series. So this here is still 6 ohms, and the value of this Vs is typically, because remember, Vs will be just simply R times Is, and if I'm converting a current source into a voltage source, it becomes Vs divided by R. So in here I'm doing is 2 times 6, okay, so 2 times 6, which is just 12 volts. All right, and we keep that in here, and I believe the 6 ohms stays the same, nothing changes. This is the other 6 ohms that is not highlighted. And then we have in here this current source in parallel with the 5 ohm. So what we do is we're gonna say this will be 5 ohms, and this will be here a voltage source, and since the arrow is moving that direction, so what I'll do is I'll say this is a positive and this is a negative. And of course the value would be, well, I'm interested into the V, so that will be 5 times 1, okay, which is just simply 5 volts, okay. And now we move to the blue part in here. This basically, I'm going to convert it to a 17 ohm resistor connected in parallel with a current source, and that current source will have to go downwards because the positive is at the bottom, and the value of that current source is simply 34 divided by 17, which I believe it should be 2 amps. Okay, so this is 2 amps. And of course we have the last one in here, which is the one that we're interested in. I'm going to highlight it in pink in here. So that will be 6 ohms, and the current that I'm still interested in, I naught, is still here. That's I naught. And then I believe those resistor, of course, this is connected in here, and these are here. All right, so that's basically the second part of the circuit. And now we can do a little bit of combination, like we can do a little bit of basically combining resistors in series. For example, the 6 and the 5, we can combine them in series. And of course, this 5 and the 12, you can think about them because they're series connected voltage sources. All we have to do is just add them. So these here become a voltage source that is simply 12 plus 5, which is just 17 volts, in series with a resistor that is 6 plus 5, which is 12 plus 5, which is also 17, well, not also, well, 17 ohms this time. And we have another one here, and that's basically 17 ohms. And the current source stays the same, and it's downward facing, so that will be 12 amps. And we still have this one here as 6 ohms. And the I naught is still the same. This is just I naught. All right, and I believe now we can do a little bit in here. For example, let me just do that. We can convert these two here together into a current source in parallel with a 17. So let me just do that. So that becomes a positive to the top, and that will be 17 divided by 17, and that's simply 1 amp, and it will be connected to 17 ohms in parallel with the other 17 ohms. in parallel with a current source going downwards, and that's 2 amps. And then the last element is the element I'm interested in, which is the 6 ohms in here, and the current I'm interested in is I naught. And now we can combine certain things. So for example, these 2 resistors are in parallel, and this source and this source are in parallel, so we can add them. So let me add the sources. So the sources, one is going upwards, that is 1 ohm, and one is going downwards. So the summation is, depending on how you want to do that, you can just tell me, well, I want to sum them into a source that is that way. If this is the case, you can tell me it will be 1 is in the same direction, and then the 2 is in the opposite direction, so I have to subtract it, and we'll get a negative 1 amp. Because I know ahead of time, well, negative 1 amp, that means my assumption was wrong to put it at the top. But anyway, it's simple to see as well ahead of time. 1 ohm is going upwards, 2 ohms going downwards, so the total is 1 going downwards. So this is what I will do. I'll just basically say, well, this here is 1 amp. And of course, the 17 and the 17 is simply, because they're in parallel, there's just basically 17 divided in half, because they're exactly the same value. And that will be 8.5 ohms. And that will be in parallel with this particular 6 ohm resistor. Okay, and of course the thing we're looking at or for is the I naught. And now that I reached this particular circuit, I can definitely continue with the source transformation and convert this source with the resistor into voltage source in series with 8.5. But I don't need to, and the reason why is because I'm after this I naught. And if you take a look at the circuit, these are 2 resistors in parallel with the current source, so I can just directly apply current division. So current division tells me that the I naught I'm interested in is simply using the source. Well, my source is 1 amp times, the resistor that I'm interested in is 6, so I'm going to pick up the other one, which is 8.5 divided by 8.5 plus 6. However, I have to put negative in here, and the reason why is because this current source, which is 1 amp, gets divided into the 8.5 moving upwards and the 6 moving upwards, because the current source is going downwards. And since the current division gives me the current upwards, and what I'm interested in is the opposite direction, I have to put that negative in here. Anyhow, so you do the calculation and you'll end up with 8.5 divided by 8.5 plus 6, and that number will be, I believe, 17 divided by 29, or just simply approximately, let's say, negative 0.586, okay, and that will be an amp.